Manual data entry still exists in every business, and it's still eating up time. Invoices, receipts, handwritten documents, even medical records. Sure, you could hand this off to ChatGPT, but that means exposing private business data and locking yourself into a black box window. So, what's the alternative? In this video, I'll show you how to build an AI workflow that extracts data, structures it, and stores it neatly in a spreadsheet or a database. It's private, it's customizable, and you can adapt it to whatever your organization needs. That may be invoices today or medical forms tomorrow. By the way, if you're new here, I'm Fraser Dorado, and I've been building large-scale enterprise software for almost a decade. And now, through my AI and automation agency, I help businesses build and scale real-world AI systems. As part of that mission, I share the same frameworks and learnings here so you can apply them yourself. And if this kind of content is useful, make sure you subscribe so you don't miss future deep dives into building AI systems and workflows. So how does an AI workflow like this actually come together? At a very high level, it simply fetches data from a storage layer. These could be scans, PDF, or any document source, processes those inputs through a multimodal LLM, and produces a structured output that is then exported back to a storage destination, whether that's a spreadsheet or a database. In this video, I'll walk you through the exact code step by step so you can follow along and have your own workflow running by the end of it. All right, with that, let's take a step back for a second. Why are we using multimodal LLMs here in the first place? Traditionally, businesses have leaned on OCR, that's optical character recognition tools like Tesseract, Parallel OCR, or Amazon TextRact, to extract data from scanned invoices, shipping forms, receipts, and even handwritten notes. And honestly, they're still great in the right scenarios. They're fast, cheap, scalable, which is perfect if you've got millions of clean, fixed template PDFs or scans. They can run fully offline, which is a big win for privacy-sensitive environments. But here's the problem. OCR still struggles with handwriting, stamps, or messy scans. It only gives you raw text, so you still need rules or regex to map fields like company or registration number. And if your document varies in layout, like shipping bills, invoices, or medical forms, OCR pipelines start to break down. That's where multimodal LLMs step in. Instead of just spotting text, they actually read and understand documents. That means you can extract structured JSON in a single step, so no messy post-processing. They're robust to layout changes, so it doesn't matter if the date field moves around. They even handle handwriting and mixed visuals better than OCR. Of course, there are trade-offs. They are slower and could be costlier depending on the scale, and because they're generative, they can sometimes hallucinate. So a hybrid workflow, usually combining LLM, OCR, or human approval, often works best in production. So here's the way to think about it. If you've got high volume fixed layouts, OCR is your way to go, no doubt about it. If you've got variable layouts and handwritten notes and need structured data directly, multimodal LLMs are your best friend. And for most real-world businesses operating at scale, the sweet spot is a hybrid solution, typically combining OCR, LLM, and human approval. But if you're not operating at a massive scale, multimodal is often the perfect standalone fit because you get rapid time to value with minimal engineering. And that's exactly what we are going to cover today. Here's the workflow we are going to put together. We'll start with files sitting in a directory, but you could easily swap that for Google Drive, Dropbox, or an S3 bucket. Each document gets passed through our Python Fast API application, where it's then passed through Gemma 3, a multimodal LLM, to pull the key fields we care about. The extracted data is then saved neatly into a SQLite database for simplicity's sake, so it's queryable and future-proof. We'll add a simple approval and edit flow with React and Next.js frontend, so you can double-check or correct fields before they're locked in. And finally, we'll make it easy to push results back into a Google Sheet or download a CSV on top of keeping the database up to date. By the end, you'll have a private customizable pipeline that turns messy scanned documents into structured, usable data, and you'll see exactly how the code fits together at each step. Now that we've got an overview of what we're going to build today, This next part is super important, so pay close attention. Before we wire everything together, I want to break down the core logic of how this AI workflow actually works. We'll walk through it step by step in a Jupyter notebook I've prepared so you can see exactly what's happening under the hood. And then when we walk through the app, you'll understand how it all ties together. With that, let's dive in. We'll start by loading our environmental properties, right? And then we're going to take an image. This is a receipt I found online. Nothing special about it. It's just a mock receipt, but it does have the address of the company, the customer address, a few contact details, a reference number, a receipt number, the date, and description, and finally the total paid amount. This is important because we're going to extract this information later on with the LLM. But we cannot really pass the image as is, and we need to base64 encode it first. So that's what we are doing here. We fetch the image path, we read the file, and we base64 encode the image. I went on to set up a few Pydantic models. One is the vendor model, purchaser, item, totals, payment, and I've tied it all together with the receipt model. We also need the receipt JSON schema because this will be passed to the model later on to give us a structured output in that format. In order to get the schema, Pydantic provides a really nice function that you can call on any model, and that's called model JSON schema, which essentially generates a JSON schema for that model. And we're doing that right here. Next, I'm using the Ollama SDK in this case. I've set up a response or a chat response. I'm calling the chat function, where I pass the model Gemma3 4 billion parameters, and we're passing a few messages. And one of these messages is the system prompt. As you can see, the role system. And the system prompt basically says that you are an expert data analyst who specializes in data extraction. Your goal is to extract the data in a structured format from the image as is and nothing else. Respond using JSON. And then we also pass a user message. So the content is, what does the image say? And in the images, we pass the base64 encoded image that we encoded earlier. I've also set a few options. One is the seed. A seed allows you to get sort of predictable responses. It's not guaranteed, but it does give you kind of similar results. And then I've set the temperature to 0 because we want more factual responses. And the schema that we generated earlier of the receipt is being passed here as format. Let's call that. Great. As you can see here, it managed to pick up the receipt number, the date, which is correct, the vendor and his address. That's also correct. Okay, the purchaser, it is not completely correct because it did miss out the forest town. In terms of items, it picked up the description. It was able to identify that it's 2. That's pretty cool. It also figured out the unit price of each. So it kind of did the math itself. Pretty cool. And then the subtotal, which is correct. It also picked up that there were coins and it put that in there. Not entirely right because that should not come under the items, but it's nice that it actually picked it up. And then you have the totals, which is correct. And the payment that was done in notes and the status is paid. Pretty good, right? For a 4 billion parameter model. I mean, the next step from here is to kind of get this more accurate is either you try a larger model or you start optimizing the prompt. But even if you do these two steps, the result is not guaranteed. And that's why it's valuable to have a human in the loop in there. So let's take a step further with upgrading the model and try to see if the output is actually significantly better or not. To show the difference, what I did is I'm calling the OpenAI model here. So we're going to use the GPT 4.0 mini. I've set up the client. It's the same system message, same user message. We're passing this exact same image data, and we're going to call the model. Great, we got a response. I'm going to zoom this out. The receipt number is correct. The date is correct. Vendor is correct. The contact number is also correct. The purchaser is correct. As you can see, it also picked up the address correctly, which Gemma 3 did not. But given it's only 4 billion parameters, I think it did pretty well. As for the items, it picked up only quantity 1. I mean, I think this is a very subjective value. Yes, in terms of description, it is 1, but it's actually 2 items, right? The quantity should have been 2, which I think the Gemma model did pretty well. Unit price, yeah, fair. And it had the totals, which is correct. And payment method says cash, pretty cool. And it put in some notes as well, received thanks. Yeah. So as you can see, bumping the model does help a bit, but not too much. And that's why I think having a human loop makes a lot of sense. Now that we've covered the core logic, let's look at how all of this ties together. To keep this demo focused, I've already built a lightweight Next.js frontend, so we don't spend time on the UI code. Our main focus will be the backend workflow. And on the backend, I'm running a fast API server with UV handling the dependency management. This makes it super easy to keep everything reproducible. Here's the main dependencies we'll be using. Fast API, we have Jinja 2, which is for templating. We have Olama to call Gemma 3 that runs locally on our system, and SQL model in order to interact with the database. For this demo, I'll run Gemma 3 locally via Olama. If you don't have a GPU or prefer the cloud option, you could also deploy a smaller open source vision model or host Gemma 3 through providers like Google Cloud, Azure, AWS, Grok, Cerberus, Scaleway, or your own isolated instance. The nice part is the logic stays the same regardless of where the model lives. With that, let's dive into the rest of the code. Starting with the database. So I've created a very simple database here with SQLite. Nothing special, it just creates a database on startup. I've then set up an LLM class where I've created a system message and a user message. I'm trying to abstract out the implementation details of how the model is being called. So that way, if you need to change the model, you just do it within this class and all of the code remains the same. You've probably seen similar patterns in LangChain, for example. So where you have your system message, your user message. I've created an LLM class where I've put the default model as Gemma 3 4 billion parameter. I've also put some default options. We've put a function to set schema in here as well. The generate function calls the model on our behalf. As you've seen this in the Jupyter notebook as well, it's quite similar. Then I went on to set up a few schemas. You've seen this in the Jupyter notebook. It's exactly the same. We have the vendor, purchaser, items, totals, payment, and the receipt. And again, a way to export the schema. Let's look at the model class. This is purely to communicate with the SQL database, but we also use this as a transfer object when we get data through our APIs and then store it into our database. I also went on to create a Jinja 2 template of the system prompt, so the data extractor prompt. It's again the same prompt where you are an expert data analyst who specializes in data extraction. Your goal is to extract the data in a structured format from the image as is and nothing else. Respond using JSON. Then I went on to set up a prompt manager. If you've seen my previous video, I also set this up there too. Basically, the prompt manager is a class I created to help you get the prompts. It has the render function and the default prompts that are available for the project. So it just simplifies things a bit. I then created a utility file where we have the function to encode an image. You've seen this in the Jupyter notebook that I walked you through as well. And a function to get all the images from a directory as a tuple. So it looks for all the extensions, that's JPEG, PNG, GIFs, SVG, and fetches all those files. I then went on to set up a service, right? And here the most important one is the process image job. As you can see, we first set up the LLM or initialize the LLM. We set the schema. Then we get all the images from the directory. This is not so important for the process itself, but this is to send status updates to the UI, which we will see in the demo. Yeah, we get the system prompt. So from the prompt manager, we get the data extractor prompt. We start a session. And in that session, we loop through all the files. We check if it exists in the database. If it exists, then you skip it. But if it doesn't exist, You encode the image, you create a list of images. So the system message, which has a system prompt, and a user message that says, please extract the receipt data from this image. And then you pass the encoded image. You get the response from the LLM, you get the extracted data, and then you save that into the database. And then we commit the session. And we also send an update back to the UI saying that all images are processed and completed. I've also created a few helper methods here. So delete all extracted data, get all extracted data, get extracted data by ID, get extracted data by file name, update extracted data. Yeah, and that's it. These are pretty simple functions. They just communicate with the database to get information or update information. I then went on to set up the server. Here it's just a fast API application, added some middleware, and we've created a trigger job stream. And what this does, it uses async queues. And the process callback is essentially streaming events to the front end. We call the process image job in here, and we run a while loop, and we send streaming response back to the UI. I've also created some helper methods here, again, for the front end to communicate with the backend. So extracted data, extract the data by ID. There's also to update the extracted data, which we will see in the demo, a trigger job, and a delete extracted data method, and one to export the data as a CSV. Oh, and one more to serve the images. That's it. Nothing too heavy, just enough scaffolding so you can run this on your laptop, but also scale it up later if needed. Now let's take a look at the demo. I've started up the servers. You get a UI like this. It's a pretty simple UI, nothing fancy. It has a trigger job, it has a delete and export, and we're going to trigger a job. And once the job is complete, you see the whole list of processed documents. Let's open one of them. Awesome. As you can see, there's the image on the left and the extracted data on the right. So essentially, it converts the extracted data into a form so that it's easy for a human to kind of review and input the data. As for the details that it extracted, let's have a look. It seems like the receipt number is correct. The date is also extracted correctly, though that's not a valid date. The vendor has been extracted correctly. That's pretty good. The purchaser has also been extracted correctly. Items have been extracted correctly as well. That's really good. So have been the totals. Yeah, okay, the payment method have not been updated correctly. So let's update that. So payment method is cash and status is paid. Even though that information is not provided in them. With that, let's try to save this. And when we open up, you should see the information in there again. Awesome. And now we're going to export that out as a CSV. And if you open that CSV, it should look something like this. You have all the details in there in a row. Pretty fantastic, right? And the best part, this setup is private, customizable, and flexible. Swap out the storage layer, change the model, or extend the UI. The skeleton stays the same. Now you've seen the entire workflow come together, from dropping raw documents in a folder to extracting structured data with a multimodal LLM, storing it cleanly in a database, adding a quick approval step, and exporting it straight into a CSV or a spreadsheet. The result, you got a private, customizable pipeline that kills manual data entry and adapts to whatever your business needs. And if you're a business wondering how to deploy something like this at scale, that's exactly what I help with. You can reach out through the links below and get a version tailored to your setup. That's the full build. No more copy pasting invoices, no risky black box tools. You've now got a workflow running on your own terms. If this walkthrough gave you a clear picture of how to kill manual data entry with AI, drop a like. And if you want more deep dives on building AI systems like this, hit subscribe so you don't miss the next one.